Okay, so my apologies, the title on this is off. I screwed up in the PowerPoint presentation somewhere. So ignore the top 2 lines. Pure substances. We've talked about elements and compounds. Both elements and compounds are pure substances. And one of the things that characterizes a pure substance is that it always has the same composition. So water is a pure substance. It's always 2 hydrogens, 1 oxygen atom stuck together. Elements are also pure substances. Hydrogen goes around as 2 hydrogen atoms stuck together. Gold is found as just single gold atoms hanging out next to each other. Another way to identify a pure substance is that all the particles are the same. Now this will probably show up on the next slide, but oh well, all the particles are the same. That's true for elements and for compounds. The other category from pure substance is a mixture, and a mixture has variable composition. When you mix salt and sugar together, you could put a little bit of salt and a lot of sugar. You could put a lot of salt and a little bit of sugar. The composition can vary. If you put hydrogen and oxygen together and make water, it's always 2 hydrogens to 1 oxygen. Always, always. So constant composition tells us it's a pure substance. A variable composition tells us it's a mixture. Examples are wood, wine, coffee. You can make coffee really strong, or you can make coffee really weak. It's not a compound. It's an element. It's not an element or a compound, although some of you may think it's an element, an essential part of life. It's a mixture. It's a mixture of lots of different things. Mixtures can be separated into the pure substances by physical means. Compounds can be separated by chemical means, but mixtures can be separated by physical means. And then we have 2 categories of mixtures, homogeneous and heterogeneous. And the prefix gives us a clue here. Homo is a prefix that means the same. Homogeneous means that this mixture is the same throughout. The top, the bottom, the middle, the outside, the inside, it all looks the same. You can't see that there's one part that's different. Another word for a homogeneous mixture is a solution, and we'll talk more about that later in the semester. It doesn't vary in composition from one region to another. You mix it up, and it's going to be the same throughout. That's in contrast. Examples first. Examples. Air. The air in this room would be considered a homogeneous mixture. Brass. Brass is an alloy. It's a mixture of different metals. And you take a brass object and you cut it in half, and if it's all brass, it's going to be the same on the inside as it is on the outside. You take table salt and mix it in water, like this illustration. It dissolves, and the water at the top tastes just as salty as the water at the bottom. It's not going to settle out. It's just going to stay mixed like that. It's not a compound, though, because you could add some more salt and mix it up. And we can also separate the salt from the water without changing what the salt and the water are. The other type is a heterogeneous mixture. Hetero is a prefix meaning different. So this one has different distinguishable parts, regions that have different properties. So examples would be oil and vinegar salad dressing, Italian salad dressing. You can shake it up and shake it up and shake it up. And you're like, hey, I mixed it. You just didn't shake it hard enough. I mixed it. You set it down, what happens? It starts to separate again. It's a mixture, but it's heterogeneous. The oil is a distinguishable part from the vinegar and water part. Another example is sand stirred into water. Put a teaspoon of sand into a cup of water and stir it around. What happens? It swirls around, and as soon as you stop stirring, the sand settles to the bottom. That's not homogeneous. There's a lot more sand at the bottom than there is at the top. There's no sand at the top. Salt doesn't do that. Sugar doesn't do that. They make homogeneous solutions. So which of these would be considered a homogeneous solution? Homogeneous mixture. And a couple of these are a little tricky. Water, pure water. Is that a homogeneous mixture? It's homogeneous. Is it a mixture? No, that's the trick. That's a compound. It's not a mixture. How about gasoline? Gasoline is a homogeneous mixture. And again, I wouldn't necessarily expect you to feel like that was an obvious thing. Gasoline is actually a mixture of a lot of different hydrocarbons, but it's homogeneous. It doesn't separate out into layers or anything. How about a jar of jelly beans? Homogeneous mixture? It's a mixture. Is it homogeneous? No. Jelly beans are in different colors, aren't they? So no, not a homogeneous mixture. How about soil, dirt? Well, that one's a little iffy. It kind of depends on your dirt, right? Some of the dirt around here, especially right now when it is so dry, it's just powdery and it's very uniform. But if you have really good soil, it shouldn't be homogeneous. You should see little bits of organic matter and different things. So we're going to abstain from answering that one. It depends. Copper, metal, homogeneous mixture? Is it a mixture? No. So then it doesn't matter if it's homogeneous or not. Any questions? Separation of mixtures. So mixtures can be separated based on differences in their physical properties. Compounds and elements cannot. An element can't be separated into separate things anyway, but a compound cannot be separated using physical properties. So these are some examples of separating of mixtures. We can separate things based on their boiling point. An example of that is distillation. We can separate things based on their state. If we have a solid and a liquid, we can apply filtration and separate them. Adherence to a surface, chromatography, we're not going to talk about that. Volatility, evaporation, we might talk about that one. So here's an example of distillation. So here we have a flask containing salt water. So you put salt and water. We know that it's a mixture. The salt is still salt, but it all mixes up and is kind of hard to separate. How could you separate it? Well, you can distill it. The water has a boiling point of 100 degrees Celsius. The salt is a solid by itself. Its melting point is extremely high. So the salt is not going to boil. The water will boil. It will go from the liquid state to the gas state. And gases expand to fill their container, so it's going to try to get out. We're going to trap it and make it go through a tube here. It's called a condenser. It's got cold water running around it. What happens when you take steam and you put it near a cold object? It condenses on there, right? You see these little droplets of water. Where did the water come from? It came from the air. Might happen to your toilet tank when it's humid in the bathroom. The water in the toilet is cool. Somebody took a shower and all of a sudden the outside of the toilet tank is wet. How does that happen? Well, there was a lot of water in the gas state in the air. When it hits the cool surface of the toilet tank, it condenses. Same thing happens on a drinking cup. It sweats. Is that the water going through the plastic cup? No, it's water from the air coming and condensing. A cup like this doesn't sweat so much because it's got double walls, and so the outside of the cup doesn't get as cold, even if you have ice cubes in it, so it doesn't sweat as much. So we heat this, the water vaporizes, and then we condense it here, and we can collect the water. The salt will not evaporate or boil like that. And so we continue that until all the water's gone, and what we have left in this flask is pure salt. And so we can separate those things based on differences in their boiling points. And this is how they distill spirits. So like vodka and rum and different alcohols are called distilled spirits. Well, they take something that would be more like wine or beer, with a lower alcohol content, and they distill it. The alcohol has a lower boiling point, and so you can separate it out that way. Important thing in this separation of mixture, no chemical change has occurred. Filtration, you probably do this if you make spaghetti. You throw the water in you pour the water in the spaghetti into a colander, and the water goes through and the spaghetti doesn't. Coffee makers use this principle also. And there's a nice summary of what we've talked about. This picture, I should probably put the picture first. Matter can be divided into homogeneous mixtures or heterogeneous mixtures. And we could separate those into pure substances. We've got two different kinds of pure substances.